Section 5.8 is about radical equations and inequalities. A radical equation is an equation that has a variable in the radicand. That means a variable is underneath the square root symbol. The way you solve things like this is you first want to get that radical by itself. So I'm going to move this minus 2 away. Notice I can do that because the 2 is not trapped under the radical sign. So we get square root of x plus 1 equals 2. And now I can get rid of a square root by taking the square of both sides. Square root and square will cancel. X plus 1 equals 4. And then we solve for x. Now, when dealing with radical equations, you should always check to see if your answer actually works in the original problem. So I'm going to do that. 3 goes in for x, and we'll see if it actually works. 3 plus 1 is 4. Square root of 4 is 2. So we get 2 plus 2. Does that equal 4? Yes, it does. So that checks out. X equals 3. In this example, we're going to look at something called an extraneous solution. That's a solution that appears to be correct until you plug it back into the original equation. So here we have a variable that's trapped under a radical sign. I can get rid of that here by taking the square of both sides. On the left side, the square and the square root will cancel, leaving x minus 15. On the right side, I end up with 3 minus root x squared. I'm going to use the square of a sum rule and create what's called a perfect square trinomial, if you will. So we square the 3, we get 9, minus 3 times root x times 2. 3 times 2 is 6. And then we square the last term. A square root of x squared is just going to be x. Now I'm going to continue to simplify by moving everything over to the left side. I want to get that radical x by itself. So I'm going to subtract 9, and I'm going to subtract the x. X minus x is gone. Negative 15 minus 9 is negative 24. And that equals negative 6 times the square root of x. I'm going to divide by negative 6. That will get rid of those there. And 6 goes into 24 4 times. 2 negatives equals a positive. So now we have a square root of x that's by itself, and then we'll square that again. So the square and the square root will cancel, so x equals 16. Now that looks like it should be my answer, but remember when you have radical equations, you have to plug it back in to see if it really works. So this is going to be 16 minus 15 equals 3 minus the square root of 16. 16 minus 15 is 1, and the square root of 1 is 1. Square root of 16 is 4. And 3 minus 4 is negative 1. So 1 equals negative 1. That's not true. That's a false statement, which means when I plug 16 in, it doesn't actually work. So therefore, this is not really a solution. So the answer to this radical equation is no solution. Now we can use the same skills we learned in the last couple of examples to deal with any fractional exponent. If I rewrite this, you'll remember that the 1/3 power really means the cube root of 5n minus 1. Now I'm not going to solve it this way. I'm just going to show you that it could be rewritten this way and they mean the same thing. I'm going to have to get this expression with the 1/3 power by itself and then take it to the 3rd power. Another tip that I want to show you is a lot of times when dealing with radical equations, it becomes easier if you take the stuff that's in the radicand, which would be this 5n plus 1, and you substitute it for something like an a. So I'm going to say 5n minus 1 equals a. And then I'm going to rewrite this equation. 3a to the 1/3 minus 2 equals 0. And so what I can do is I can solve this for a, and it's a little easier when I do it that way. And then when I'm done, I plug the value in for a, and then I solve for n. So here I'm going to isolate this a to the 1/3 by adding 2. Divide both sides by 3. And now I can get rid of a 1/3 power by taking that to the 3rd power. So I'll take both sides to the 3rd power. 1/3 and 3 is 1, so this just becomes a to the 1st. I'm going to cube 2 and get 8. I'm going to cube 3 and get 27. So now I know that capital A is 27, so I'm going to take that and plug it back in here. So a over 27 equals 5n minus 1, and now I can solve for the n, which is the letter that I originally wanted to solve for. I'm going to add 1, which means I'm going to add 27 over 27. Because that's the same as adding 1. So over here it goes away. On this side I'm going to get 35 over 27. Divide both sides by 5, or I could multiply by the reciprocal, 1/5. That's the same as dividing by 5. 35 and 5 cancel, leaving a 7. So I'm going to get 7 over 27 is what n equals. In addition to having radical equations, we can also have radical inequalities, and those are inequalities that have variables in the radicand. They look just like equations, except instead of adding and subtracting, they have greater than or less than. Something like this would be a radical inequality. Here you see a concept summary for how to solve inequalities. One thing you have to watch out for is if the index is even, square root, fourth root, sixth root. If it is, then you have to identify values for the variable which the radicand is not negative. So you have to look for the absolute value sign. And then solve the inequality and test some values to see if they work. So here we have a radical inequality. And the thing with this is because it has a square root, because it has an index that's even, we've got to look at the radicand and make sure that it's always going to be positive, because you can't take the square root of negatives. So we want to find out where the 4x minus 4 is going to be bigger than 0, where it's going to be positive. And this is going to become part of our solution. So let's solve this first by adding 4 to both sides. And then we'll divide both sides by 4. And we find out that we're going to have to be bigger than or equal to 1 in our solution, because anything smaller than 1 is going to create a negative in this radicand, and we can't have that. Now we'll solve the inequality just like normal. We'll try to isolate the radical, and we'll square both sides. So we'll move the 2. Square the left side and the right side, because the square and the square root will cancel. So 4x minus 4 is less than or equal to 16. Add 4. So 4x less than or equal to 20. And then divide both sides by 4. So we end up with x less than or equal to 5. Now we have to combine these two. We're looking for values that are bigger than 1 and smaller than 5. Now I'm going to write that this way because they can be combined in a single inequality, because we have to be between 1 and 5. Now the last thing that we're going to do is test a value that's in all three of these regions. We're going to test a value that's smaller than 1, between 1 and 5, and that's bigger than 5 to make sure that those values are going to work. So here I've taken the original inequality and I'm going to test a value that's in all three regions. I'm going to do f of 0, which means I'm going to plug in a number that's smaller than 1 to see if those numbers work. Plug in a number that's between 1 and 5, so I chose 2. You can do 3 or 4, whatever. And then I also chose a number that's bigger than 5, so I'm going to do 7. You might want to pause the video and come back and see which one of these regions work. So here we have the different areas. When I plug 0 in, I get a negative square root, so that doesn't work. That area is false. When I get a number between 1 and 5, it's true. Everything works out fine. And over here, 4.9 is not less than 4, so this is false also. Which means my solution is what I thought it was. The numbers between 1 and 5. I can put that on a number line as well. Close circle on 1. Close circle on 5, and all the numbers in between work, so we shade it inside.